These are the three relations R1, R2 and R3, which is a partial order relation on this set S that has elements 1, 2, 3, 4, 5, 6, 7, and these are the corresponding Hasse diagrams respective to each relation. Now in this video will just write down the ordered pairs from the Hasse diagram. What are the ordered pairs of the relation? So if you look at this relation R1, then this is a very the smallest reflexive relation that has only reflexive pairs as the ordered pairs in it. So R1 is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Okay, so this R1 is these are the ordered pairs in R1. Now let's look at R2. So I'm not going to write all these reflexive pairs separately here. So let me take one set REF pairs. So this R1 is basically nothing but REF pairs. Okay, so REF pairs is equal to this. So when it comes to R2, R2 is REF pairs, means reflexive pairs union. Now I will look at this is one. Now look at this. This is just one connected component. So what are the minimal elements in it? 1, 2 and 6 are minimal elements. One, 2 and 6. These are minimal elements. So I will start from the minimal element and I will write all the ordered pairs with the minimal element as the first element. Means one is one minimal element and one is related to 3, one is related to 4, one is related to 5, because these comes in the upward path from 1. One is not related to 7 because of course you do not have an upward path from 1 to 7. You can go from 1 to 3, 4, 5, but from 5 you have to go down. Similarly, there is no upward path from 7 to 1. So 1 and 7, they are incomparable because they are not related from any side. So incomparable elements, if I take also incomparable elements or incomparables, then one of the incomparable is 1 and 7. So I'm taking them as a set, but each set, you know, I'm taking them as a set, okay, 1 and 7, which means if they are incomparables, which means neither 1 comma 7 is going to be your R belonging to R2 nor 7 comma 1 belong to R2. Okay, so 1 comma 3, 1 and 4, 1 and 5. Similarly, what is the second minimal element? 2 is the second minimal element. So 2 is related to 3, 2 is related to 4, 2 is related to 5. Okay. Any two minimal elements are incomparable. 1 and 2 are incomparable. 2 and 6. There is no upper path from 2 to 6. There is no upper path from 2 to 7. So from 2 you can go to 5, but then you have to take a downward path. So there is no upper path from 2 to 6 or 7. So they are also incomparable because from 6 also you cannot reach 2 through an upward path. And from 7 you cannot reach to 2 through an upward path. 7 to 5 and then you have to go down. So 2 and 6, 2 and 7, they are incomparables. What is the third minimal element? Is 6. So 6 is going to be incomparable to 2 and 1 also. Any minimal elements, they are incomparable. So 1 and 6, 2 and 6 they are okay. I've already taken 2 and 6 here. Now 6 and 7. From 6, the upward path, if you follow upward path from 6, you get 5. And that's it. If you want to go from 6 to 4, then you will go in the upward direction, but then from 5 you have to descend. Similarly, if you want to go from 4 to 6, you can go up to 5, and then from 5 you have to descend. So 4 and 6 are incomparable. Similarly, 3 and 6 are incomparable. That's it. So all the minimal elements are done. The ordered pairs with respect to the minimal element as the first element in the ordered pair is done. Now what we will do? We will go one step above the minimal element. So from one step above is 3. That is also one step above from 2. So when 3 and 4, 3 and 5, but then 3 is uh, 3 and 7 are incomparable, 3 and 6 are incomparable. So 3 and 6 I have already written here. Add 3 and 7 here. Now from 6, one step above, 6 is one minimal element, one step above is 7. Let's see from 7 what are all the ordered pairs that is possible. 7 and 5, and then 7 and 4 is incomparable. There is no 7 and 4 I have written here. So 4 and 7 is incomparable. 7 and 3 is incomparable, that is already here. 7 and 1 is incomparable, that is here. 7 and 2 is incomparable, that is here. Now we will go two step above the minimal elements. Two step above the minimal elements, 1 and 2 is 4 combinedly. Means for 1 and 2 both, 4 is two step above. So with respect to 4, you get one ordered pair 4 and 5. Now two step above 6 is 5. So and 5, there is nothing above 5. If there is nothing above 5, then you can't get any ordered pair with 5 as the first element. So that's it. Means from 3 step above 1, 2, 3, yeah, 3 step above 1 and 2 you get 5, and from 5 you can't get any other ordered pair. So 5 here is a maximal element. Okay, minimal elements is this, maximal element is 5. What is the maximal element? If element is a maximal element if it is not related to any other element. uh, so in a Hasse diagram, if there is no upward edge from a node, then that is a maximal element. So 5 here is a maximal element. What is minimal element? Minimal element is uh, if no other element is related to that element, then this element is a minimal element. Like if you look at 1, 2 and 6, there is no other element from which there is an upward path to 1 or 2 or 6, so they are minimal elements. If you look at this R1, then every element is minimal as well as maximal. Every element is minimal as well as maximal. So these are my list of incomparables, and these are the ordered pairs, reflexive pairs union this, that you get from this Hasse diagram. Now just think about this. If this is your set S 1, 2, 3, 4, 5, 6, 7, then for this set, what is the total number of possible ordered pairs? The set S is 1, 2, 3, 4, 5, 6, 7. The total number of possible ordered pairs is cardinality of S into cardinality of S, which is 7 into 7, 49 total ordered pairs are possible. Of which in your relation, you have reflexive pairs which is 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 plus 7, 19 ordered pairs are part of your relation R2. Okay, so out of 49 ordered pairs that is possible between these elements, 19 are there. 19 are in the 19 belongs to R2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus 7, 19. Now look at here for 1 and 7, it's possible two ordered pairs are possible. 1 and 7, this is 1, and 7 and 1. Two ordered pairs are possible, right? So for every, what is the number of incomparable elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 incomparable pairs regardless of their order. So the total number of ordered pairs is 49, right? Number of elements in S cross S is 49. Then can I not say that this 49 will be equal to 2 into number of elements in this incomparable set, 2 into number of elements in this incomparable set, plus reflexive pairs, number of elements in reflexive pairs, plus 2 into this, 2 into number of elements here. Can I not say that? Means that this has to be the case, otherwise there is something missing. Means you can take it as a verification. If you have, if this is something that is being asked and you have to check if you are right or not, then this you can think of it like a verification method, that twice of the number of elements here plus number of elements in reflexive pairs plus twice the number of elements here has to be equal to 49. Why I am taking twice here also? Because if 1 and 3 is here, then definitely 3 comma 1 will not be here, because of antisymmetric, right? Then what I mean to say is that 2 into number of elements here plus number of elements in reflexive pair plus 2 into number of elements here will give you total number of ordered possible pairs, total number of possible ordered pairs for this set S. Let's check if I am right or wrong. So number of reflexive pairs is 7. 7 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 into 12, 24 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 18, which is equal to 49. Okay. Now if you look at this one, R1, the number of reflexive pairs is 7. This is 7. So plus there is no other ordered pair as part of R1. But then it means what? It means that every such pairs have to be coming from your incomparables. So number of incomparable has to be 21. That's when it will become 2 into 21 plus 7. And anyways, if you when we will do combinatorics, you can find that this is nothing but any two elements that you choose, they are incomparable. So number of ways of choosing two elements out of 7 elements. This is a problem of combinatorics, and it's easily you can find it out that it is 21. I'm not doing it here because I have not started combinatorics. Now let's get into this R3. I will erase this one because I have to. Okay, I'm erasing this R2. Now we will see R3. What are the minimal elements in R3? Minimal elements. 1 and 2. These are minimal elements. Every other element has some other element that has an upward path to itself. Like for 3, you have a upward path from 1 and 2. For 5, you have a upward path from 2. Okay. What are the maximal elements? So what is the maximal element? That from that element there is no upward path to any other element. So such an element is 7. and such element is 6. Which means, if to define maximal element, it is simply that there does not exist any x such that maximal element, if m is your maximal element, then m is not related to any x. Okay, so 6 and 7 are your maximal elements. Now I will have incomparables on this side and R3. So R3 is reflexive pairs union. First minimal element is 1. So with respect to 1, you can have 1 and 3, 1 and 4, 1 and 6. Okay, 1 3, 1 4, 1 6, 1 7. And then whatever comes from this side, 2 and 5, they are incomparable to 1. 1 and 2, 1 and 5, they are incomparable. Another minimal element is 2. So with respect to 2, 5 and 6, 3, 4 and 6 and 7, all of them are 2 is upward in the upward path from 2. So 2 and 3, 2 and 7, 2 and 4, 2 and 6, 2 and 5. And 1 is incomparable. So 1 and 2 is already here. Now moving one step above the minimal element. So from 1 with one step above of 1 is 3, one step above of 2 is 3 and 5. So we will see every such pairs where 3 and 5 is the first element. So with respect to 3, you can have 7 in the upward path, 4 and 6 are in the upward path. 3 and 5, you cannot get, if you cannot get to 5 from an upward path from 3. Similarly, you cannot get to 3 from an upward path from 5. So 3 and 5 are incomparable. From 5 and 6, but rest of them 5 and 4, they are incomparable. 5 and 3 is incomparable. So 5 and 4 is incomparable. 5 and 3 is incomparable. Okay, let me write it like this. Now two step from minimal elements. So from two step from 1, you get 4 and 7. So from 4 you can get to 6, but from 7 you cannot get anywhere because 7 is the minimal element. And from 4 you cannot get to 5. So 4 and 5 is one incomparable. And from 7 you cannot get anywhere. And two step from 2 is 6, and from 6 you cannot get anywhere. Three step from 1, 1 2 1 2 3, three step from 1 you get to 6, and there is nothing you can get above. So this is it. These are your ordered pairs in your art. Are we missing anything? Are we missing anything? That we can check by counting 2 into number of elements in incomparables plus 2 into number of ordered pairs hairs plus whatever the number of reflexive pairs. Their sum has to be equal to 49. If it does not come 49, it means we have done something wrong. 1 2 3 4 5 6 7 8 9 10, 11, 12, 13, 14. 2 into 14, 28, plus 7, plus 1, 2, 3, 4, plus 8, 34, 35, 43. So there's something wrong, somewhere something is wrong. Let's look into this. Let's look at incomparables first. From 1, 5 is also incomparable. You cannot go to 5, and from 5 you cannot come to 1. Okay, so 1 and 5 is here, 1 and 2 is here. Okay, what are the incomparables with respect to 1, 2 and 5? What are the incomparables with respect to 2? 1. What are the incomparables with respect to 3? 5. What are incomparables with respect to 7? With respect to 7, actually, 4 4 is incomparable with respect to 7. 4 and 7. 6 is incomparable with respect to 7. 6 and 7. And 5 is incomparable with respect to 7. 5 and 7. I think now it's okay. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 into 40, 2 into 14, 28, plus 7, plus 1, 2, 3, 4, 5, 6, 7, means 40. So this is 28 plus is 34, 35, 49. Okay. Thank you very much.